Hey everyone, welcome back to Faraday Research. It is Sunday night, and the last couple of weeks I've been working on this motor. I haven't really been showing too much of it, but I figured now is a good time as any to do an update on what I've done. So from my road trip yesterday, I went and I got another coil here. This is 1 pound. So Tesla goes by mass. So I measured the two weights of the two coils. This one's about 100 grams heavier. Okay, it's a little bit off, but irregardless, I'm just going to keep it as it is for now. But I have to get more of these coils. So these coils are very special. They're a lens-free coil. All right, and I stumbled upon this a couple nights ago by accident, and it exhibits zero lens, or very, very little, very minimal. So the motor can run freely without any drag. I shorted out the coils. It makes no difference. It does not put any kind of braking effect on this. So all that stuff I'll probably put in Patreon. There is one design for a lens-free coil in there now. This is a new one I've kind of discovered totally by accident. So anyways, if you can defeat lens law with these pulse motors, you've almost won the game. All right. So there's another configuration. It's called the zero force motor. I got materials. I might even try to make the zero force motor. And it's going to be quite a bit different than this motor here. So underneath here, you got the traditional pulse motor. So there's the Hall effect sensor. That's from a 3D printer. And then you got a coil down there in the back. That's about 600 turns with a standard iron core. Pretty basic. It's pretty much the Robert Adams device. I'm using the spark gap switch again. I've done the mod to the actual spark gap switch. There it is there. And I also posted a video the other day a picture of the radiant energy spike that's going through there. So I know I'm getting the green turquoise type spark, and that's what Tesla was working on, the radiant energy stuff. So before we get into the rest of the video, if you haven't subscribed to the channel, bottom right hand corner. Also, if you like the video, give me a thumbs up as well. That helps. So I haven't really done too many videos on this because I really wanted to just focus on it and try to get something new, trying to innovate something new. Okay, so we got the Robert Adams motor. I'm running it at 12.3 volts. I'm getting about 100 to 110 milliamps. I would like to get a little bit lower, but if I work at it and get the fine tuning on it, I could probably get it. The other night I had it down to 60 to 70 milliamps, which is really, really good for an Adams motor. Now, here's what I've learned over the past couple of years. So I've got the Adams motor. I know how it works. I know how to get great performance out of it, but I had to take it to the next level. So this is what I've done. So I've got the Adams motor below, and above it, I have a generator. I got north, south, all the way around. Oh, my coil got dislodged there. North, south, all the way around. This coil's coming out of place here, so it's touching the wheel. So anyways, I got north, south coming around, making a traditional generator. But now I'm using the lens-free coils. These lens-free coils now, because there is no load on the system with the lens-free coils, there's no stress on the Adams motor. It's not pulling any extra amperage to run it. It's running freely. Now I can put 5, 8, 10, 20 coils, as many coils as I want around this, and generate AC power. So if you remember this LED display here, I was using that with my my new battery cell technology. So I've got 30, I believe it's 32 LEDs on here. So what I'm going to do is I'm going to fire it up, and I'm going to get these coils within proximity, and this whole array of lights are going to light up. And it's tax-free. It's not taking any extra amperage for the Adams motor to run it. Okay. Plus, I also got the other light here. It's hitting almost 200 volts, pulse DC, coming from the Adams motor. So I got the Adams motor creating power. Now I got a generator that's lens free on top that's generating more power. And to boot, this wheel here is acting like a flywheel. Like if I shut the power off, this wheel will spin for about almost a minute before it actually stops. So now I got a flywheel. So I'm implementing 3 different systems into one unit. And my preliminary tests are showing some pretty good results with actually the current too. I put my amp meter to this, and it was showing me it was pumping about 1 amp AC, which is way higher than what I thought it would. So I was very impressed with the amount of current that it was generating. So I figured, well, I got 4 magnets on this now. I might even go to maybe add another 4, so I'd have 8 magnets on this north south all the way around, like a traditional generator, and be able to pulsate and create more power, even more current. So yeah, tell me what you think, guys. Comments below. Also, my links for my Patreon, all that stuff's there. Give me a thumbs up if you like the video. And I'm going to get it fired up. Hopefully my coil down here doesn't move out of place again. Sometimes it moves, so, and it hits the wheel and then stops it dead. So I'm going to, this power supply here actually just runs the switch, nothing else. So get that going. So now you can see I got the pulsing going. All right, so I'm going to get her going here. Give her a good spin. I'm just going to jack up the power just to get the RPM up. I'll put it at 15 volts just to get the RPMs going. And then now I'm creating inertia. I'm creating centrifugal power. Now this is like a mechanical battery all on its own. So as soon as I get it up to a good speed, as you can see now on here, I figure I'm getting about 600 to 900 RPMs, maybe a little bit more. I got to get my tack hooked up to it. So okay, we got it going pretty good. Okay, let's drop it down to about 12 point. Okay, I'm going to do it. I'm going to go a little higher. Let's get it to about 12.5 volts. I'm going to let the motor settle in a bit here for a second. Adjust my reeds, my proximity sensor, try to get the most speed I can. And then I'll get it generating some power here. Okay, I got a good, so it's running at about 110 milliamps. I could probably get it lower. I'll have to work on the tuning and get it down. All right, so let's get the first coil in. Okay, I got some power going there. All right, I'm gonna shut the lights off and you can see I'm generating power, extra power now. Try not to get it too close. There we go. All right, so, and look at my current. It's about the same. It maybe goes up to 112, so that's, what, 10 milliamps maybe? Lens effect on it, which is nothing. And I'm getting all this power. I'm lighting all these 32 LEDs. This is AC going in it, by the way, and they're still working quite well. So the most it's pumping out is about, maybe the lens effect is about 10 milliamps. It goes from 11 to 12 and back down. It's holding at 11 right now. And I'm getting quite a bit of power coming off it. It's generating current. I'm going to bring it a little bit closer, and you can see how bright it is. So it is generating a decent amount of power. So now I've got the Adams motor, and now I got this generator on top generating even more power. Plus the Adams motor is generating this. That's about 200 volts, pulse DC. So yeah, generator is really pumping. Now imagine if I had 6 of these coils around here, how much power I'm going to get AC. I measured the one coil here. It was putting out about 5 volts AC. If I get, say, 5 coils going, 6 coils going, wow, this could be really, really good. So put the lights back on. You can see the wheel, how fast it's actually spinning. And look, it's not drawing any more current, maybe 10 milliamps. So that means the lens effect on this is almost next to nothing. I've shorted out both coils together, just take my word for it, nothing happens. There's no lens. In an actual traditional generator, the motor should actually start slowing down. Now I also got the mechanical power, the inertia, the centrifugal motion as part of the energy of the system. So I got like 3 things happening here. So yeah, I'm very impressed with the amount of power I'm getting out of it. Very happy. Yeah, they're LEDs. It's, you know, they're small current, but it's showing that I'm actually generating some decent voltage. See, if I bring the coils very close, then the lens starts taking effect, but I could keep it, you know, within a half-inch distance from the wheel, and it's generating power. So, you know, it's like in baby steps. I mean, you know, definitely creating extra power for almost nothing. I know the LEDs don't draw much current. That's fine. I'm not worried about that now. I just want a proof of concept of my lens-free coil here. And, yeah. So, that's pretty much it. I got to work on the wheel a bit. It's still making a lot of noise. Like, the power's off now, so it's just basically winding down on its own. I think it's hitting my coil again. Yes, it is. That's what's happening. I got to fasten that coil down a little better. But, yeah, this thing will actually run for about a minute. I'm trying to get the wheel balanced and stuff like that, so that's been a bit of a challenge. I've been working on that. Eventually, I will get it, and it'll be perfectly balanced. But yeah, good results. I'm generating power in 2 different ways, as well as the mechanical power that the flywheel here is throwing at it. And I'm using lawnmower wheels. I wanted to make a generator where you can literally go either to Amazon to buy your components, electronics and all that, and the rest of it you can buy at freaking Home Depot and make a pulse motor over a Unity device. So I'm quite happy thus far. I gotta wait for that electronics place to get more coils in stock. I like to get 4, maybe even 6 of them going. If I can get that many coils, you know, it's a little tight squeeze on this side here, but if I can get one here, one here, one here, one in the middle, and one offset here again, that's 6 coils. And that would make this thing power a huge amount of, get me a lot of current to the point where I can hook all this stuff in parallel, multiply the voltage, put it through a full wave bridge rectifier, and then run the system on a cap bank and see if it will actually sustain itself. That would be very interesting to see. So, or greatly reduce the amount of power that it would take, or increase the length of time that this motor would run on its own with no assistance. So I think I'm on the right track. Give me a thumbs up if you like the video. And yeah, we'll see everybody soon.